Okay, cool. So we're gonna get started. Don't worry, you're not gonna be coding until like basically the second half of all of this. So take your time with downloading data sets and not. But welcome to Introduction to Python and Pandas. Really quick, just to gauge, how many of you guys like have used like Python notebooks so far? Maybe some of you guys in DST10 already gone through it. Cool. Okay, awesome. Then how many have you used Pandas already? Okay, cool. So kind of half and half. Okay, awesome. So for the people that have used pandas before, this will kind of be like a review for you all. Maybe you'll learn something new too. Get a little better at it. And then for the new people to pandas, welcome. It's a lot of fun. So to introduce ourselves, my name is Radu Manea. I'm a senior data science major at UCSD, obviously. And then this is Keagan.
And I'm Keagan. I'm also a senior data science major here at UCSD. I just want to say thank you guys for coming to the first DS3 workshop of the year. I think we have around 10 more planned this quarter and then a bunch in the next quarter. So I look forward to seeing you guys in the future and learning more about data science.
Oh yeah, so for you guys that are on Data Hub, just go ahead and open it, and then whatever server you have access to, you can go ahead and use that. And just open up a new Python notebook, and you can name it whatever you want. DS3 Workshop 1, Intro to Python, whatever you want.
All right. All right, so you guys might be asking, why do we use Python for data science? Why not Java? Why not C? I know there's a little bit of R use in data science, but why Python in particular? So the first reason is it's super easy to learn and use. If you're trying to do data analysis or, machine learning models, the last thing you want to do is have to be, dealing with, tough syntax and working through all these problems. And, why would you not want to use something that's super easy? And in the future, we're going to show you guys how much easier the Python syntax is than, some of the other languages like Java. Another reason is that it has a bunch of libraries and frameworks. Obviously, in this, we're going to be talking about Pandas as one of the frameworks. There's other ones such as NumPy, sklearn, a bunch of others. I think I Googled it. There's in the tens of thousands of libraries and frameworks that you can use. The third reason is that it's also very well supported. So there's a bunch of Python programmers out there, a bunch of people using it for data science. So when you run into problems, it's very easy for you guys to be able to find solutions online using websites such as Stack Overflow. And the last reason, it's named after Monty Python. Actually, not a reason, but I don't know. I think it's a little funny. All right, so what is Python? Python is a programming language. It's interpreted, object-oriented, a high-level programming language, and it has dynamic semantics. It's interpreted. What does interpreted mean? Interpreted languages are not directly executed by the target machine. It is different from compiled programming languages such as C or C++. It's read and executed by some other computer program known as the interpreter. It's also object-oriented. Python, like many other object-oriented programming languages, is organized around objects. Everything in Python is an object, even ints, strings, lists, dictionaries, classes, everything. It's a high-level programming language, which means the syntax is very easy for humans to be able to interpret, which obviously makes it very easy to read, and you don't have as much syntax requirements as compared to other languages. So one example I'll show you guys is, if you're trying to print in Python, it's a lot more simple than trying to print in Java, in which you have to define a class, define a method, and then do system.out.println. You also have dynamic semantics, which is basically the type that you declare in Python. So dynamic objects are instances of values contained into constructs in the code, and they exist at the runtime level. We can assign to one object multiple values since it'll update itself differently from static semantic languages. So it's like what we said, if we say A equals 2, we can change it to, A equals whatever. We can make it a string. We can do A equals hello, and we're not going to run into errors. Whereas in Java, if you do int a equals 2, and then you want to change it to int equals hello, which would be a string, you're going to get an error. Whereas in Python, it works just fine. So how do we run and write code in Python? The best way is just to use a simple text editor, although today we're obviously going to be using Jupyter Notebooks, which is a little different. And to write code, you just write it in Python, save it as a .py file. Then you can do run Python3, whatever your file name is, .py in your terminal, and you'll be able to run your code. These are some great text editors. You have VS Code by Microsoft, Sublime Text, Atom from GitHub, PyCharm, and Vim. All right, now we're going to talk a little bit more about Jupyter Notebooks. So there's two types of cells in Jupyter Notebooks. First, you have what's called a code cell. So in this, you can run code, and then the code will, or like the output of the code will just appear under. This is one of the reasons that Python's, pretty easy to use, that you can very easily test your code in these Jupyter Notebooks where, the function, you just run it. Next, we also have a markdown cell. This is more for like writing. Maybe if you want to do a presentation in Jupyter Notebooks, you can write text. You can do all these different formats, make lists. It's very cool. All right, next we're going to talk about importing libraries. It's very easy. You just basically do import whatever your module name. So you can do import pandas, import NumPy. And then if you want to use an alias, so like a little nickname for your library, you could do, for example, import pandas as PD, which is typically what most people do. Import NumPy as NP. And finally, you can also import only select parts of the library. So typically, like in sklearn, you do, actually, I'll show you the example. You do from sklearn, import preprocessing. This would just be if you don't want to import the whole entire library, you only need the preprocessing. Yeah. All right, next we're going to go over a little bit of syntax. So in Python, unlike Java, you don't have any semicolons, which is pretty nice. But you do have to deal with white space, which can be a little bit annoying. Another thing is that strings, you can use one quote or two, but you can't do them together. So if you did a string like this, where you have two quotes and one quote, it won't work. So for example, on this function, I did not do the white space correctly and had error. So typically after you have a colon, you're going to want to tab one over. So basically this should be scooted over a little bit and you won't get that error. All right, next we're going to talk about some identifiers. Identifier is basically just the name that's used to identify a variable, a function, a class, a module, or any other object. Typically, they start with a letter or an underscore. It could be capital or it could be lowercase. And then it can be followed by numbers. But you're not really supposed to use, or you can't use like special characters such as the @ the $sign, %. And these identifiers are case sensitive. So if you add a variable name or identifier that's all caps and it's the same word, but it's lowercase, those will not be the same variable. All right, now we're just going to talk about a couple of Python variable types. So you have, your basic numbers, it's just integers and floats. Strings, these can also just be individual characters, or it could be longer, it could be words, it could be sentences, you could even have paragraphs in these strings. We also have lists and tuples. Lists and tuples are very similar, except for tuples are immutable, which means you cannot change them once you've declared them. Then finally, we have a dictionary, which is also pretty similar to lists and tuples, but it's structured in a way with keys and values. And we'll get into that a little bit more later. So here's just an example of what like some types would look like. So if we just have a 2 with no decimal point, and we want the type, it's going to be an int. Whereas if we add the decimal point, it'll be a float. And then strings will typically show up as str as the type of the class. All right, so let's go into creating lists and some list operations. So creating a list is pretty easy. You just need the brackets and then whatever you want to put in your list, comma, and then you can keep putting stuff in your list if you want. This is just how you create it. You could also create an empty one with just 2 brackets. With lists, it's very nice. You can put whatever you want in your lists. It's not restricted to just, if you make a list, it's not restricted to just only integers or just only strings. You can mix and match. So in this example, we put Bob, a string, then we put an integer, a float, Then we put another list in there because, you know, we can do that, and a tuple in there. So that's very cool. Now we're going to talk about some operations. So once you've already declared your list, if you want to add something to it, you can use append. And then you can also use remove if you want to remove it. So in this case, we add a 1 to the list, and then we put in bad data. As you can see, that's what's in our list at after we run line 20. And then if we want to, we can remove that, and we remove the bad data, and then we just have the 1 list. Next, slide. All right, so this might be a little confusing, but since it sounded like most of you guys have used Python or have coded before, it should make perfect sense. But lists are actually indexed at 0. So if you want the first element, you need to use a 0. So as you can see on list 4, we index it with 0, which will get us the first element. And yeah, we can also get the last element by using -1. And then if we want to get parts of the list, not just a single number, we can use the colon. So on this one, for example, we're going up to the third element, third index, which is actually the 4th element of the list, but it does not include that 4th element of the list. So as you can see in our output, we only get 1, 2, 3. Yeah, and then we can also do this in reverse if we put the digits at the beginning. So for this one, we go to the first index, which is, you know, the 2nd element of the list, and we get everything after that. So that'd be 2, 3, 4, and 5. And then we can also mix these two, and then we would just get what would be left over, what would be common between those. So like I said, tuples are like lists, but immutable. You also use parentheses instead of brackets to declare your lists. Or yeah, tuples. All right, now we're going to talk about dictionaries. So like I said before, dictionaries are very similar to lists and tuples, but they're key value pairs. So the way, we'll actually go over this later, but so for example, if we wanted like some sort of data structure where we'd have, you know, for example, people's names and their ages, we could do a dictionary like this where we have, you know, Bob, and then his age is 12, Joe 17, Bill 18. And so the way you get the keys, which would be, you know, Bob, Bill, and Joe in the previous example, is just by doing dictionary or dot keys. We can do the same and only get the values by using dot values. And then finally, if we want to get both in the form of, you know, basically the value pairs in the form of tuples, we can use dot items. And then one thing that's pretty important to note is even after you use these, you know, dot keys, dot values, dot items, you cannot like work with them like lists yet. You need to use the list function to turn them into a list. So that way you can do like your indexing and stuff like that. All right, so now we're going to talk about how you modify these. So with a list, it's very easy to modify. You just put the index that you want to modify in right here into the brackets next to the name of the list, and then you can set it equal to whatever. So in this case, we set it equal to 10, and then when we printed it at the index 0, we got 10. Dictionaries work very similar, but instead of using the index, you use the key name. So for example, let's just say maybe Bob's 13 now. We can change his age to 13 just by doing that. All right, now we're just going to go over some basic math in Python. So obviously you have your addition, subtraction, multiplication. This one right here is the exponent. So right now we're doing a to the b. A is 4 to the b power, which is 2. So that's 4 squared, which would be 16. Now we get into division. This is just your regular division, a divided by b. But if you want to use, if you do 2 division signs, it's actually called floor division, which means you basically just get rid of the decimal point. So in our example, we do 7 divided by 2, which usually would be 3.5, but since we're doing floor division in this case, it just gets truncated down to 3. So this is basically just how you define a function. Pretty boring function, not gonna lie, but you know, it is what it is. Notice how, unlike that previous example, we have the white space here, which allows us to actually run it. This one, yeah, it's kind of a boring function, but this is the basic setup. In the future, you guys will write hopefully a lot more complicated functions than that. Now we're going to talk about some conditionals. This is kind of the structure of conditionals. So you usually use an if statement at the beginning. So in our example, we're going to check is 5 equal to 1. Obviously, this is not true, so we would keep going down like our logic series. Now we're going to check is x equal to 5. X is equal to 5, which means then we can, you know, basically run this code at this point. One thing to note that you need to make sure of is that when you are doing these conditionals, you need a double equal sign. You cannot just use the single equal sign, otherwise you'll get an error. Single equal sign is for assignment. Double equal sign is for basically doing conditionals like this. There's a lot more conditional operators though. For example, you have the does not equal sign. So in this case, if we wanted this first one to run and we use the does not equal to, so if we had if x does not equal 1 and we had x is 5, then this first line would be run. Does not equals is very similar to the not operator. Can't remember the specific cases when you'd use one or the other, but they're very similar. Then you also have or and, which is kind of how you do like multiple checks. So in this example, I just wanted to show you. So if basically if we have a true or a false, then this will get run. Whereas if we have a true and a false, it'll not get run. So the or operator basically just needs one thing to be true, whereas the and needs both of these, both of your conditionals to be true. All right, now we're gonna get into loops. So this is kind of your basic structure of loops. It might want to be noted that in data science, we try to avoid this when working with tabular data, just because we have more advanced methods of kind of going through the data, such as, you know, using your pandas library. But this is the basic structure of it. So it's whatever you want your value to be. This is just a random name that we chose as I in an iterable, and then it'll go through each element of that iterable. And in this case, we just print it. So you guys saw that I was using range before, so I might as well explain it. Range is pretty cool. It lets you basically just form a list of just, you know, numbers of however you want. So if you just put in, you know, whatever number, like a 10, for example, it'll start at 0, count all the way up to 1 minus your number. So in this case, it goes from 0 all the way up to, you know, 1 minus 10, which is 9. But there's also multiple or like some other arguments you could put in there. So you can have a stop, a start, and then whatever your step is. So in the second example, I'm going to start at 10, and we're going to go all the way up to 1 before the 20. So that would be 19. We're going by 2. So we go 10, 12, 14, 16, 18. If I set that 20 to be 21, then we would still get that 20 out at the end of this list. But because I set it at 20, it goes 1 before, so it only goes up to 19, and it stops. We can also do something similar and use negative numbers to count down. So in this example, our start is 10, and then we're going to go all the way to -1, and we're going to be going down. Next, we're going to talk about iterating through a list or a string, because you can do both. So yeah, in Python, we can iterate through values in a list or a string. So it's kind of that same syntax as we had before for, you know, whatever we want. In this case, it's letter in test string, and then we're just going to print each letter. We can do the same thing with an array. They happen to have the same output, even though, I don't know, could have done something different, but whatever. Now this is basically the same thing as what we did before, but this is helpful if you want to loop through it using the index rather than the actual item. So in this case, the letter is the actual letter in this array. So for example, this letter will be P, and it'll be Y, T, H, O, N. Whereas in this case, the I is actually the index. So on our first iteration of this loop, I will be 0. And so we have to plug that 0 into our array to be able to pull out the whatever index we have going. But this is also very useful. It's the range inside of the length of whatever array we're working with. Finally, we're going to get to list comprehensions. These are pretty cool. They're basically just for loops in one line. When I first learned these, I felt like I was so smart because I don't know, it's pretty cool. Basically the syntax is, whatever value we want at the beginning, and then we're going for whatever our element is going to be inside of the iterable. So for example, we got some Pokemon in a list called Kanto starters. So we're going to go for our Pokemon in the Kanto starters. So basically Pokemon will be each individual entry of the list. We're just going to print them. So basically we just got the same list again, not very cool. But what is cool is that we can now do different functions on top of these strings that we have in our list that we wouldn't be able to do before. So now we could do, for example, right here, same kind of formatting, but we're going to do dot upper. And that'll basically cause all the letters in each individual string to go to uppercase. So now we have basically all uppercase Pokemon names. Finally, if we want to combine a little, combine our if statements into there, the if statements go at the end. So for example, right here, if we only wanted, Charmander from this string or from this list, we could do if Pokemon is equal to Charmander. And then the only Pokemon that gets returned is Charmander.
Okay, cool. So now that we're done with a little Python warm up, we're gonna start getting into pandas. Has everyone gotten the data set downloaded for whoever wants to follow along? Okay, yeah. If you can, just go ahead and if you have downloaded it, go ahead and get in the same directory as wherever your Python notebook is. It's from Kaggle. Oh yeah, for people that didn't get here. Sorry. It's on Kaggle. If you look up Pokemon, it should just be the first one. I can pull up the link if you guys need it. Okay, I'll go ahead and get started because we have a little bit until we have to code anyway, so Keeks can help out with whoever still needs help with it. But okay, we're gonna get into some more fun stuff here with pandas. So what is pandas? Unfortunately, it's not related to real pandas. The term's actually derived from panel data. And it's a Python library that's used for data science, pretty heavily used along with NumPy, Seaborn, Matplotlib, a whole lot. And it's a very good tool to use when you're working with a large data set. However, not too large. Once you get into the millions of rows, when you have too many records, sometimes because pandas doesn't have direct parallelism when you're using a virtual machine, it's not the best tool to use. PySpark and Dask are a lot better when you have high levels of computation needed. But it's great for starting off with, and it's always good to use for some general analysis. And why pandas? Pandas uses fast, flexible, and expressive data structures designed to make working with relational or label data both easy and intuitive. And also why pandas? The Pandas API is super well documented. They have plenty of detailed examples of how to use each function and how to work with large sets of data. So let's learn a little bit more. We're finally going to start. So once you have an IPython notebook open, in the first cell, you're just going to type import pandas as PD and import NumPy as NP. And yeah, like Keagan had mentioned, those are just shortened so that you're not typing pandas and NumPy every single time. Just makes it a little bit easier. And also, once you have that downloaded data set, just make sure that it's in the same directory as the notebook. So you can just access it directly. Okay, and once you have pandas and NumPy imported, we can take a look at what pandas has to offer. So first step, in order to work with our CSV, we have to read it in. If you want to use, if you want to go to documentation at all, you can go to the, just look up pandas Python online and you can find all the documentation for the different functions we're going to work with today. But basically to read in your CSV, you're going to go ahead and initialize a data frame. You do this by having some sort of name. DF is just a generalization for data frame. And you're going to set that to pd.read CSV. And the name of your file should be pokemon.csv. And if it's not, you can copy and paste whatever it's named as and throw it in there. And then if you want a little sneak peek as to what data is in your CSV, you can use you can use the head function. So you can do df.head and it'll show you the first 5 rows of your data. How's that working for everybody? Did anybody get that? Anybody getting errors? Also, yeah, if you guys have questions at all throughout all of this, just feel free to raise your hand or have Keagan come and help you out. Okay, so to talk a little bit more about what a data frame is. So DF is short for data frame. Data frame is essentially any sort of tabular data. And we can change the name of DF to whatever we want. So in this case, we're just going to work with Pokemon. So same thing applies. Pokemon equal with pd.read CSV. And then I also want to talk a little bit about the dot head function and the dot tail function. So just how the head function gives you the first 5 rows of your data. The tail function gives you the last 5 records. But you can also do some cool stuff with it. If you add an integer into the arguments of head or tail, you can get however many rows that integer is. So like, for example, if you wanted to see the first 100 rows, you could use dot head and then in the arguments, throw in 100. And also just that's kind of like the first thing you do when you do upload a CSV like this, because you kind of want to see if you got everything loaded in correctly, and you don't want to display too much information. You don't want to be slowing down your computer. And then also a really neat function that Pandas has is the dot describe function. And what this does, it gives you kind of just some standard statistics about your data. So basically, for example, in each column, it'll give you the count. So how many rows are in each column. These typically should be the exact same. And then the average. So these are usable, like these are very useful in numerical columns. Obviously not as useful when you're dealing with strings or list records. And then the standard deviation, the minimum value, the 25th, 50th, and the 75th percentiles of those values, and then the maximum value in each column. And lastly, keep in mind that some of these values may not make sense or be too useful. For example, we don't really care about the average Pokemon generation or Pokédex entry. So yeah, just be careful so that you know that whatever column you're working with, these values actually make sense for that kind of data. Okay, so you might have heard already that 80% of the data science machine learning process is cleaning and processing your data. Unfortunately, the most fun part, which is the actual model building, only really takes up about 20% of your time, maybe even 10%, I would say. So cleaning is really, that's like the most important and necessary part of it. It's like the garbage in, garbage out process, right? If you have bad data that doesn't make sense or is unnecessary, it's not going to be turning out into a good predictive model. So basically, the first thing we're going to do is kind of select some columns that we want to work with. make sure that there's no missing values. And we can also add new columns with combinations of features. So when we're doing feature engineering and machine learning, this is also very big part of the actual cleaning of the data. So first thing we're gonna do is just check data types. Pandas has this feature, D types. The reason that we do this is to make sure that each column of our data frame has the correct type for what we're doing there. So for example, HP should be an int, that's correct. And then our strings, type 1 and type 2, those are gonna be objects. So this looks pretty good right now. Our legendary column is either true or false, so it's a Boolean. So it looks good and we're ready to move on. The reason this is important is, for example, let's say you're working with survey data, and one of your survey questions is, how old are you? And there's a text entry box. If someone types in, let's say 21, that's gonna come out as a string because they're typing it in. It's not gonna be seen as an integer. So when you try to take an average of a bunch of strings, right, like 19, 20, 18, whatever those numbers might be, it's going to be read as string. So you want to make sure you change that column to an int column instead. So it's just important to make sure that you know the kind of data you're like dealing with. And then we can also drop columns. Once you start working with really large data sets with multi-millions of rows, it gets pretty computationally heavy for your machine. And so we want to drop columns that we don't need. And we can do that with the drop function. And then also we can add columns. So here we just import random really quickly. You guys can do the same thing if you're following along. Well, the way that we add a column is we have our data frame here, Pokemon. And the same way that you would look inside of a list, right? We add brackets and let's have a new name. So we want new Pokedex ID to be our new column. And inside of that column, we want to specify what's going to be in it. So we have a random int, and all this does, this is a function that's saying we want a random integer from 1 to 10,000 for I in range length df.name. df.name is the column that we're working with. And we're just saying that for each record in that column, we want a number from 1 to 10,000. And so, of course, if we look inside of our database now, you'll see that we have this new column that we didn't have before called new Pokedex ID. Okay, everyone that's following along got that? You guys are good? Cool. Feel free to stop me if I'm going too fast, too slow, whatever it might be. Okay. Also, we have the ability to rename columns, right? So for example, our column sp.atk, if someone's reading that, doesn't really know what's going on, it might be kind of tough for them to understand what that might mean. So we want to change it, for example, to sp.attack, right? Oh wait, wasn't supposed to show you that yet. You guys try to go ahead and see if you know how to rename a column. Give you guys like 30 seconds. Yep. Okay, so it looks like a lot of you have already gotten it, but just to take a look here, we're basically going to say we're going to use this rename function that Pandas has, And so now we're going to say Pokemon, which is our data frame, is equal to Pokemon, which was our old one. And we're going to rename the way that we use the rename function is we specify either rows or columns. In this case, we're going to have our column renamed. And so inside of this columns argument, we're going to add a dictionary. And the key is going to be the old column name. And for each column that we want to rename, so in this case, sp.atk, the value is going to be the new column name. And if we wanted to rename multiple columns at the same time, we would just add in a comma right here, and we'd add another entry to the dictionary. So if we wanted to change sp.def to sp.defense, we would do the same thing and just add another entry into the dictionary with the key as the old name and the value as the new column name. Okay, so sometimes you might want to replace data. We'll see this again later on with null values too. But when we want to replace data, who knows if this is a good way to do it or a bad way to do it? Okay, well, it might look like it's a great way to do it at first, right? We're using the replace function in pandas to replace all instances of 1 to Canto, because we want the generation to, instead of have a number that we might not know what that means, we want it to be the region that they're from. But as you'll notice, if you haven't noticed already, now in the numbers column, there used to be a 1 there, and now it says Canto. And so especially when you're doing stuff like this, you want to make sure that you're replacing values only in the column that you want those values to be replaced in, or else stuff like this comes up, and now your data is a little bit messier than it was before. And the way that you would do that is the same way that we've been working with columns. You would just add brackets behind Pokemon and signify what column name you want, and then use the dot replace function. So like I mentioned before, there's a lot of information about null values. Null values can be the death of your data science project if you're not doing the right thing with how to deal with them. So in different contexts, there's different things that you would do with null values. For example, right, here's a bunch of null values, right? We create a series with all nulls. How can we fill them? We use something called fill NA. This is another pandas function. Basically inside of the parentheses. So first of all, call, that's our column. In this case, it's just a series to use as an example. And we're going to say fill NA, and in the parentheses, whatever we want to fill all null values with. In this case, we're just going to fill them all with ones. So while before they were all null values, now they're all ones. And then another thing that you can do is filling nulls with, let's say, the mean, right? So if we had a series, and in this case, the first element is 2, and then 10 null numbers or null values, and then a 1 at the end. By using fill NA and using the mean of this column or series, now all these null values here are 1.5 because the average between 2 and 1 is 1.5. And so stuff like this is important because, for example, if we were to fill all of these with 0, then it would obviously drastically impact our average. So if we were trying to calculate salaries and there's a bunch of null values and turn all to 0, it's going to say the average salary is a lot lower than it actually is. While if we fill it with the average, it doesn't change the average. So important things to keep in mind when you're working with null values to make sure that you're not negatively affecting the quality of your data. And then also we can just get rid of them completely. Pandas has another useful function called drop NA, and as you would guess, it drops all null values from the column. In this case, it in a data frame, it would drop the entirety of the row. So only useful when you don't want the entire row anymore, because sometimes you lose a lot of information when you're dropping any row with a null value. Okay, so we've done this a couple times already, but just to go over it more aggressively here, selecting data. There's a few different ways to do it, and we'll go through each example here. So all of these three do the exact same thing. They'll all return this. And let's go through each one individually. So the first one is selection by column. You can get access to a column by using its name in the same kind of format as you would access an element from a list using as an index, right? So if we had a list and we'd say we want the first element, we'd say the list at in brackets 0. But then for a column, you just put inside the brackets the name of the column. And then we can also select by indexing, and the same way as with the brackets, but here we're using dot notation. The only difference is that when you have columns that have spaces in them, you can't really use dot notation because obviously like it'll be white space in between. So just keep that in mind that when there are spaces, it's probably better to use selection by column. The first version of it. And then lastly, you can do selection by index, and that's with this pandas function called iloc. What this does is that the first parameter in these brackets is the row. In this case, we just have a colon, meaning that we want every row. And then the second value inside of these parameters is what columns we want. So in this case, we want column 1, which is the second column. And once again, you can see that it returns the exact same thing. So you use iloc on your data frame and then just specify the row and column that you want. And we're going to go through a quick little example here. How would you get the third row, so the index 2, and get the Pokemon stored in that cell? You guys can go ahead and try it too. So think about the column that you want, right? You're probably going to want the name column. So figure out what index that is. And then the third row is going to be index 2, since it's going to start with row 0, 1, and then 2. Okay, so if you haven't gotten it yet, that's fine, but we're just gonna show you this quick solution. You're gonna use your data frame .iloc, and then you want the row at index 2, which would be the third row, and then the column at index 1, which would be the name column. Okay, so Pandas also has something called the loc function. There's not that much different between loc and iloc. So for example, if you use loc or iloc here and just say you want the second row or the row at index 2, third row, then it's going to show you the exact same thing using both functions. However, there are some slight differences. For example, loc can index by string name and iloc only indexes by integer, right? So when we use loc, if we want all rows in the name column, we can just type name instead of having to index it as 1. However, with iloc, you can't actually do that. It's going to give you a value error because you can only index by location with an integer. So keep that in mind when you're using the two. I honestly prefer using iloc, but both are easy to use. Probably honestly, loc is probably better, but yeah. Okay, so you guys have probably noticed while before we were getting like a nice data frame that came out and it looked really clean. Now we're getting kind of like an ugly looking list. Those are called series. And all that really means is basically a column is stored as a series. And a series is just a one-dimensional array containing information from a row or a column. So we looked at how we can select columns earlier through indexing and by the column name, and now we can also select multiple columns by putting them in the list. So while before we had, if we wanted the name column, we would just have brackets around name. Now we're going to use a second set of brackets to identify a list. So we have a list of column names here, name and total, and we put that inside the brackets, and the same thing applies. And then this also works for single columns. It's a little bit unnecessary, but if you wanted to put the column by itself in a list, you could. But that's just more of a proof of concept. Okay, so let's talk about some useful pandas functions. This is stuff that I probably use it kind of on a daily basis. For example, conditionals. This is always important when you want to get a subset of your data. So the same that we were talking about with like the regular Python conditionals, right? So let's say that we wanted all Pokemon that had a type 1 that was water, right? So what we would do is we have our Pokemon data frame, and then in our brackets, right, we want to get an index. So we're going to index at the type 1 column when it's equal to water. And by doing that, as you can see, we get all of our type 1 water Pokemon. And so it works through a Boolean series. So like we had mentioned before, a column is a series. So it's going to evaluate as a Boolean at each row. And if it's false, it won't return those rows. And when it's true, it returns those rows. Okay, so what if you wanted more than one condition to select data? In this case, what you would do is same thing applies, except now you're going to throw parentheses around to tell Python that we want this conditional and we want this second conditional. So when both of these are true, then it'll return that row. And so in this case, we want to type 1 water and type 2 ground. And so as you can see, all the Pokemon in this list that were returned are water and ground Pokemon. Okay, so we're going to do an exercise. Pull out the names of all Pokemon with the type 1 of fire and type 2 of fighting. Give you like a minute on this so we don't take too much time. Okay, so it's very similar to what we saw in the last slide. And so what we're going to do is same thing. We're going to add a double conditional. So our first one is type 1, setting it to equal to fire. And then we have our type 2 equal to fighting. And so when both of these are true, those rows will be returned. And we obviously want the name column. So we're going to take a look inside that name. And this is what we have. If yours looks like that, then good job. And if it doesn't, also good job. You're learning. Okay, so let's say we wanted to pull out all Pokemon whose health is below 100 HP that are fire types. Same thing applies, except still we have 2 conditionals, except this time instead of using equals to equals, we can use a less than. So all these conditional operators are useful with pandas and they all work. And again, the most important part about this is especially when you want to subset data, this is a great way to do it. Okay, so also we can work with proportions with pandas. So for example, if you wanted to know what proportion of the total Pokemon are poison types, it's super easy to find out. And we do this through summing and dividing. So you can sum a numerical column or data frames columns by using the sum function in pandas. And you can also use count on non-numerical columns. And you can also use dot shape. Dot shape is another function. It just takes the shape of your data frame. So if we look back, actually, I think we can see it somewhere. Maybe not. Okay. Basically, what this does. Well, yeah, no, I was looking for like the shape documentation, but the shape function just takes the length of your database, and then also like how many columns you have. So for example, like shape 1 would give you the number of columns you have. Shape 0 gives the number of rows. So it's kind of like a count. And so we can calculate proportions that way. So we have our conditional here, type 1 being poison. And we're going to take the shape 0, which is the amount of rows. So how many Pokemon are type 1 poison? And then our Pokemon total is going to be just the shape. So like the amount of rows in the entire data set. And we're going to just do poison divided by a Pokemon total. And those are two integer values. So we can use it. We can use division to get that ratio. Okay. What is a portion of Pokemon that have type 1 of fire and who have type 2 of fighting? This was gonna be tricky, so I think we're just gonna go through it right away. So first of all, what we're gonna do is get this conditional. So type 1 equals fire, and then we take shape 0 to store the amount of rows, or the amount of Pokemon. And then we want fighting and fire. So we have type 1 fire and type 2 fighting. And then we take the amount of rows there. And again, we divide fighting fire by 5. Okay, another super useful pandas function is dot apply. So for example, what if you wanted to subtract a number from an entire column? What if you wanted to use some specific function for every entry in a column? That's where apply comes in. And you can pass a function, into an apply call, and it'll perform that function on every element in the column. This one's like honestly probably the most useful one so far. So definitely check it out in the documentation. So right now we're gonna subtract the mean attack from the attack category. So first thing we're gonna do, we're gonna grab the mean by using Pokemon, the attack column, and we just use the dot mean function in pandas. And that'll save it as the mean number. And then to subtract the mean, we're going to use the lambda function. Has anyone used lambda functions before? Okay, we'll have another slide on lambda functions, but basically it's just like a mini defined function. So you tell Python that it's a lambda function by specifying lambda. And then all this is saying is that for every value x, the new value is going to be x minus the variable mean. So the way that we apply this is now on the Pokemon attack column. We want to use dot apply, and then in the arguments we're going to add subtract mean, which is our lambda function that we defined on this line. So we're just going to apply this function to this column, and as you can see, now some of these numbers are negative because we've subtracted the mean from them, and they were probably lower than the mean. Okay. Let's talk about lambda functions. So lambda function is a small anonymous function, right? It has no defined parameters, anything like that. We don't have to write all the extra lines. A lambda function can take any number of arguments, but can only have one expression. So yeah, the best way to think of it is just a little mini function, right? So this is basically the equivalent of this if you wanted to imagine it as an actual function. But it's just a quick, easy way to get small operations done on a different amount of rows. As for grouping, you can take a data frame and group the entire thing based on the unique values of a column and then aggregate how you feel. Picking how you want to aggregate your information and setting a function up can be the tricky part. I still struggle with it to this day. It took me like 3 weeks to figure out how to group and aggregate this summer at my internship. So it's tricky, but once you get the hang of it, it's very useful. So for example, let's say that we wanted to group Pokemon based on their type and then sum together each column of the groups. The way that we would do that is we take our data frame, which is Pokemon, and we use the pandas group by function. So we're going to be grouping by the type 1 column. Now, as you can see, that index of the rows is now type 1. So we have each unique value in type 1. And then the rest of the columns are aggregated by the sum. And then you can also group on multiple columns. So the way that you do that, you just put your column names in a list and put them in the arguments for the group by, and then same thing, just do dot sum. So as you can see now, you have each combination. So for example, with type 1 bug, you have the combination of every type 2, and then same thing goes for water, and then all the ones in between it. Okay, so this is where we can add the aggregate function too. A group by ag is basically we can use like our own functions to group everything using this aggregate function. So in this case, if we wanted to get the mean of every other column grouped by HP, now what we can do is use group by and then our column name HP and then aggregate on the mean. So all these columns now have their mean values for all HPs of 1, 10, 25, and so forth. Okay, merging, joining, and concatenating. For the sake of time, we're only going to be talking about merging here. But these are all ways to join tables. This happens a lot. Companies store their data in many different places. And sometimes they'll have a key in one table that you want to join with another table. And so there's a lot of different ways to do it. In this case, we're going to use merge. But for example, here, if we have our types data frame, and let's say that this was just all it had was the information for the type of each Pokemon, but our indexes match with our name data frame, which just has Pokemon names. We can join these tables on the index. And the way that we do that is through this merge function. So we take one table, but let's say we start with name, and with that data frame, we want to do dot merge. And then we inform pandas of the other table that we're trying to merge with. In this case, it's types. What this does, left index and right index, is basically saying that when you set them both equal to true, that means that they're matching. And so if you only set one to true or the other one to true, it'll only follow like the index of that table and then disregard the other one. But in this case, the indexes match up, and so we're good to go. And then, yeah, this is what it's going to look like. Okay, thank you for attending our workshop, everyone. Good luck using Python and Pandas. Hopefully you learned something new today. Check out the DS3 Instagram if you want to stay connected with Keagan or myself. Our LinkedIn's are on the screen. And yeah, hope to see you guys at other workshops rest of the year. And good luck with the rest of your quarter.